I'm around too many nerds. One of them would have told me by this point.
That's the idea, is that like dark matter could be in this room with us right now.
Well, how'd the star get there?
Yeah.
It didn't just poof and magic. Well,
so at the beginning of the universe, there was just hydrogen and helium. But I looked up how big the bulge is, and I was like, would we be able to feel the bulge if it was like the size? Hello, everybody, and welcome to Open Orbit. My name is Hunter. Today we are joined with our guest, Raven. Raven works at Fisk Planetarium with me, as some of our other guests have, and Raven also does research at NSO. Do you want to tell us a little bit about that?
Yeah, so I, of course, work at Fisk. I do naving and presenting. I do too much. It's a problem. But at NSO, I mostly research, you'll never guess, the sun. But my main focus is on sunspots and faculae, which, unlike sunspots, which are dark spots on the sun, faculae are bright spots on the sun. And we're trying to see how those can be used to track the rotation of the sun and kind of calculate the spin of the sun, which is weird and complex and interesting. But eventually we want to do it on different stars other than our sun, which we know enough about. And I've been doing that since the summer and continuing that now for about a year so far.
Yeah.
That's what I spend most of my time doing.
I just realized we introduced NSO without like saying what it is. NSO is the National Solar Observatory, right? Mm-hmm. And naving, do you want to tell us what naving is at Fisk?
Oh yeah, I forgot. We use so much slang, both in astrophysics and at Fisk.
Yeah.
So naving is what we call navigating or controlling the planetarium. And why did my brain stop working? Naving or controlling the planetarium. And so we're basically flying through the solar system. We have a variety of like trackpads and buttons and different things so that we can fly from planet to planet, fly outside of our solar system, look at a bunch of cool stuff. But we just call it naving for short. That includes naving for laser shows, which is just putting a bunch of cool stuff on the dome.
Okay, so today we are going to be playing a game where we pose a question, fact or fiction, to each other, and the other has to guess whether it's fact or fiction. And if we guess wrong, then we lose. And if we guess right, we get a point. Yay! Okay. So, do you want to start us off with yours, or do you want me to start off?
You have to start off.
Okay.
Obviously.
Okay.
Of course.
Okay. Are you ready?
Yes.
Okay. So, fact or fiction? A planet has been discovered in a system with 4 suns.
A planet has been discovered in a system with 4 suns.
Yeah. Or 4 stars.
4 stars.
However you want to say it.
I always end up saying suns, and it makes some people mad. I want to say fact. This seems like it could happen as long as the stars aren't of equal mass. I think it's possible if maybe this other stars were orbiting a central one and there could be a planet somewhere in that mix.
Why couldn't they be equal mass?
I think if they were equal mass, it would be too unstable of an orbit to collect around to form a planet, like to collect dust and matter around and then compact it to form a planet. Mm-hmm. That's just my initial thoughts.
Nice.
Are you going to tell me?
Is that your final answer?
That is my final answer.
Your final answer is fact.
My final answer is fact. I want to believe that it's real.
Okay, yes, it is true. Yes, so you got the point. It is true. And one of these systems is called Kepler 64b, or PH1. It was discovered by a bunch of amateur astronomers. They call themselves the Planet Hunters, I think. And the Planet Hunter Project. So they call it PH1.
Okay, that makes sense. Yeah. I was about to ask. Those are very different classification names.
Yeah, but it was discovered using the Kepler telescope data. And it was discovered by this amateur astronomy group plus some researchers at Yale. And they found it. And it's a system of... The planet orbits around 2 main stars, and those 2 main stars orbit around another 2 main stars, and the whole entire system orbits around one center of mass. And so actual planet orbits around 2 stars, but because those 2 stars orbit the other 2 stars, it actually does orbit 4 stars. It's pretty crazy.
That's wild. It's giving 3-body problem.
Yeah, but like 17.
Yeah, but too many. Too many.
I think we're at 5 bodies right now. But yeah, it's pretty interesting. Yeah. And there's others that have been detected as well, but that's just one of them. And yeah, it's pretty cool.
It is very cool.
So yeah, congratulations on the point.
Gosh, Sub's going to make fun of the fact I'm still saying that. He put it on his poll as like in every little fill out spot. He put yippee, yippee, yippee.
Who?
Seb did.
Oh, nice.
Because I always say it every time at the end of a song when it becomes dead silent at Fist. I go, yippee, yippee, yippee. And nice. It's very entertaining. Okay. Are you ready for your first one?
I'm ready. I'm nervous, but I'm ready.
You said fact or fiction. That's how I started, right?
However you want to start it, but yeah.
Okay.
Sure.
Fact or fiction, Neptune's clouds and its cycle of clouds follow the 11-year solar cycle.
That's way too specific to be, like, fake.
Everything I say is really specific.
And it has to do with the sun. You would know that. So I'm going to say fact.
Is that your final answer? Do you have any supporting thoughts?
I'm going to say that it's a coincidence that they line up and that it's likely not related, but it's a coincidence. Maybe. I couldn't see, like, the only thing I could see, like, affecting it would be, like, solar wind on Neptune, but I don't know anything about, like, solar wind at that distance. So I don't know. But yeah, I'm going to say fact.
You are correct.
Oh, God.
So Neptune only gets 0.1% of the light, like its light intensity is 0.1% comparative to like Earth of how much light, solar wind, etc. it gets. But current studies are showing, and they're looking at research from like the 90s to current from a couple different observatories, one of them being the Keck telescope.
Nice.
And they've noticed that the cycle of clouds, or so how dense they are and how visible they are, does directly correlate with the solar cycle. And so their initial presumptions are that it is an actual correlation. But the other idea is that it could be that the amount of UV reaching Neptune can affect how visible the clouds are. So either way, even if it's just affecting visibility, it's still correlated to the solar cycle.
Interesting.
So when the UV rays peak and there's more solar flares, there's more clouds visible, at least, on Neptune.
Interesting. I like that one. That one's really interesting. I never would have guessed that.
That's the one that I found out digging for things about Aurora for my show. I found that article and I was like, that feels fake. And then I was like, it's a NASA article, so I hope it's not. And lo and behold, it was very, very real.
When I was doing research for this episode, I went primarily to NASA stuff. And there's multiple times where I was like, is that true? And I was like, it must be. If it's NASA.
Hopefully.
Yeah, hopefully.
Questionable.
Yeah. Well, that's really cool. That's interesting. I never would have guessed that. So Neptune's great blue spot. Is that what we call it? The big blue spot? Great blue spot?
I think so.
I don't know. But that's we haven't seen that in a long time, right?
I don't think so. I think it's opposite from us currently.
Okay.
Because, it takes about 290-something years for Neptune to go around the sun.
Oh.
And then its rotation is also very long.
Do you know about anything with that in the solar wind? Is the blue spot affected by it?
I don't know. I didn't see anything about that storm specifically in that article and in that research, so I'm not sure.
I'd assume not, but I wonder if the visibility of the clouds changes. The visibility of the blue spot. Yeah, I don't
Especially if there's clouds layered on top of that. If that storm's lower and deeper, then maybe the clouds would make it invisible if they were layered on top.
Yeah. Interesting thought. Cool. Okay, so we're 1 for 1 right now.
1 for 1.
Awesome. Okay, wait. How many questions do you have? Because I prepared a few.
I have 5 because
Cool.
I can't find my other ones, but I also have things in my brain.
Sweet. And we have 2 textbooks on a table, so we can just flip through it and be like, true or false. Okay. Are you ready for the next one?
Yes.
Okay. Recently, we have detected dark matter explicitly. True or false? Or fact or fiction?
We have detected dark matter. That's so vague.
Like we know historically, like dark matter has been observed cosmologically because we can see galaxies.
All the gravities.
We can see all the gravities from the galaxies. We can see, we can see galaxies behaving as if there's more gravity in them than what we can see. And so dark matter has been hypothesized as just this matter that we can't see or detect. And there's been many different ideas of what it could be. But the only way that we've like known of its existence is from seeing its effects gravitationally in large scales. So my question is saying we have now detected it, or my statement is saying we have now detected it explicitly. Like we have measured a particle of dark matter. True or false?
I'm going to have to go. I think I'm going to go false. Based on the fact, I feel like I'm around too many nerds. One of them would have told me by this point. This sounds like something that at least one person I know would be hype about.
Yeah.
So I feel I'm going to go with false or
nice.
Fiction.
Yeah, that's exactly true. Yes. It's false. So yeah, and I was thinking that. I was like, she probably would know. Yeah,
unless it happened like yesterday, and which would be incredibly. No, I still feel like there would be a Canvas announcement of like, guys, did you see? did you see?
Yeah, but yeah. So the cool thing about this is that like, despite dark matter taking up 27% of the universe, we still haven't like explicitly detected it yet, other than measuring it gravitationally. We still have never made any explicit detection of it. We don't know what it is. We've had previous theories of it, such as WIMPs, weakly interacting massive particles. And that theory has been tested over and over and over again. And like modern physicists are now saying like, we've tested all of our ideas of what WIMPs would be if that's what dark matter is. Mm-hmm. But now they're on to other ideas that have existed before as well, such as axions. I don't know how to pronounce that. Axion? Is that what it is? Axion? Axion? Yeah, that's how I thought it was. But yeah, okay. Axions. And those are more of the more prominent idea right now with modern physics. But yeah, they've been like looking forever for dark matter. We've been looking for it for decades. And all of the like particle accelerators that we've built, the big loops, our largest one is in Switzerland right now, I believe. It's the Large Hadron Collider. And they have been trying to like collide particles together at really high speeds to see if there's any energy loss that isn't detected. They're trying to make dark matter by colliding particles together at really high speeds. And if there's any energy loss that they don't account for, they're saying that must be dark matter. But so far they haven't found anything. There's been a lot of other ways to detect it too that have not gone so well.
Oh dear.
There's been liquid xenon detectors to detect visible matter interactions with WIMPs. And that's like extremely sensitive to energy deposits. So that's similar to what they're doing with the 2 visible matter things. And then they also have like super cooled crystals. And those are kind of cool. If it interacts with a particle of dark matter, then it vibrates, and they're put underground because underground there's less likely any interaction between like particles from the sun or from the atmosphere. And so they put it deep underground, so anything that like would interact with it can't because it's being absorbed by the ground, except for neutrinos. Neutrinos are the like where we're getting to such a sensitive level of detection now that we could be detecting neutrinos, which are really weakly interacting particles coming from space. Mm-hmm. And those go like straight through the ground sometimes. And we could detect those as dark matter. And I think the first like hypothesis of dark matter was that it was neutrinos, but then we figured out that neutrinos are not dark matter. And yeah, there have been a lot of other tests as well, but they've basically excluded the idea of WIMPs, and they're now onto axions. The way that they're trying to test for axions is by having two really large magnets. And if an axion goes through it, then the idea is that an axion acts like a wave more than a particle. And through the two magnets, it would turn into a photon. And then they would detect that photon as a microwave, a really faint microwave. That's the idea right now.
Well, have they considered just going out and taking a scoop of an area that they detect dark matter?
That's really far away. And they're really, really large spaces. Because like where we detect dark matter is over like really, really big spaces, like clusters of galaxies or in an entire galaxy itself. But I think it like that's the idea, is that like dark matter could be in this room with us right now, but yeah, exactly. It may be inside of us, I don't know, but like it's just really hard to detect at that level or something. I don't know. It's wacky. Trying to figure it out. Yeah. And so yeah, it's just super interesting. I learned a lot about dark matter when researching for this because I didn't know much about it before. But yeah, I hope I explained it well enough. I think I said some pretty big words there that You said big words. Yeah, I did. I don't understand a lot of them very well.
It's more the pronunciation that always gets me. I can't. Yeah. I read something and I'm like, actually, I've never spoken a word before. I don't know how to read. Yeah. Never mind. Yeah. I'll just stay silent.
I do that a lot when I'm presenting. Yeah. Yeah. But yeah, congrats. You're 2 for 2.
Yippee, yippee. Okay. Let's see. I don't want to go in order.
I have to hide the answer so you don't cheat.
I can't read.
Oh.
Have you considered?
I assume that you're illiterate.
Yeah.
Oh.
I'm a woman.
What does that mean?
Of course I'm illiterate. I never learned how to read.
No, I said I assumed you're literate.
Oh. I thought you said I assumed you're illiterate. And I was like, yeah, duh. Oh, God. No. I just can't know. I have contacts in and they make my eyes watery. So if I try and like focus on reading upside down, it's lost on me. I'll
put my notes back here.
Okay, I'm more concerned about you reading mine. Except mine don't have answers on them that you could actually read. So it would be useless. Okay, I'm going to skip from 2 to 3 because who cares about going in order? Okay. Fact or fiction, the direction of a galaxy's spirals can indicate the direction of a star's rotation within the galaxy, as well as the rotation or orbital direction of the planets in that galaxy. Does that make sense?
Yeah.
Okay.
Yeah, like the spirals go like they point out opposite to the motion of the spinning.
Yes.
Okay. I don't think we know a lot about like the movement of galaxies. I sure don't. so that's a good one. I'm gonna say true because it makes sense to me. Most things tend to spin in the same direction when a system forms, but I think that would break down when galaxies collide with other galaxies, and then you get elliptical galaxies, but you're specifically talking about spiral galaxies. So I would say true.
Okay, final answer?
Yes.
Okay, it's false.
Dang it.
I'm so sorry, it's false. So we thought that at one point it was kind of like, maybe that makes sense. Like if it spins this way and it spins oh yeah, it would keep going in that direction. But it's just has to do with the total angular velocity of all of the things that are coming together, and they'll kind of cancel out, and then that is more so what causes the spin of both the stars and then the planets. This is, of course, a side of like things colliding or interacting, like with Neptune or Uranus, those probably got hit, and then that's why they spin wonky. But from the basis of this is a baby little system that's just forming, it has limited to do with the direction of the spirals.
Interesting.
Though it would be cool if it did.
That's to say that like a spiral galaxy is still in its like baby stages. Like it's not
like
developed.
nothing weird has happened yet.
Okay.
Nothing like things coming in like
interesting. So
3i Atlas.
Are you saying that many stars orbit in opposite directions around the center of the galaxy?
They can orbit, both the stars can orbit around the galaxy in any direction, in multiple directions, as well as the actual stars are orbiting and like rotating in different directions as well.
Interesting. I think what made me think that it was true is seeing the animations of galaxy mergers.
Yeah.
And when you see them, it like, I guess I just, like, they often depict gas in it. And it seems like it's just all spinning together, but I don't know. Yeah, it's really interesting. I'm going to have to look into that more.
Well, because also you can think about the center of the Milky Way, like looking at Sagittarius A star. If you look at all of the stars orbiting around it, they're not all going in the same direction either.
Yeah.
And those have been pretty well tracked and documented because they were like, hey, there's this weird thing in the center that everything's going around. But you can see that they're on all different planes in all different directions.
So if our galaxy was to develop more, then we may get some type of... No, because two stars really don't collide that often.
No.
Interesting. Yeah, I'm only like relating it to like the formation of a solar system. And that's all that I've ever learned about is like the formation of a solar system and how it all kind of averages out to about the same direction usually.
I feel like everyone focuses a lot more on like solar system formation, even though like there's like a couple other processes that are like relevant to it, but everyone's like, "Ooh, solar system formation." I'm like, "Well, how'd the star get there?" It didn't just poof and magic. Well,
bit.
Kind of, but that's besides the point.
Yeah. Well, interesting. Yeah, I don't know anything about like the motion of galaxies, so that's really interesting to me.
Mine are all over the place as far as like, I feel like I have like one of every topic.
I tried to get like a little varied too.
I have a variety.
Good. Okay, I'm excited. Okay, are you ready for the next one?
1 second. I'm slowly dosing myself on caffeine.
That looks like a circus in a cup. What is that?
It's the same thing I got last time. The
sugar?
Mistletoe. Yes, the mistletoe rebel.
Nice.
With soft top parfait
Mistletoe
style.
rebel?
Yeah.
With what?
Soft top parfait style.
This is not an advertisement, I don't think. Is that Starbucks?
No, it's Dutch Bros. Sponsor me. I love Dutch Bros.
Cool, I've never been there. Dutch Bros, I'm coming for you. I'm going to try
I should bring you Dutch Bros next time we work together.
Yeah, that sounds great.
I'm using it to stave off my headache that is not from lack of caffeine, because I haven't had caffeinated coffee in like a month. This is just a headache of the evil variety.
I'm sorry.
It's the weather. I blame the weather.
Oh. Well, a circus in a cup sounds like a good way to stave off the headache.
A circus, oh my god. Okay,
all right,
now
are
I'm
you
prepared.
Ready?
Yes.
Okay, so you have 2 points. I have 1. I'm very, very upset with myself right now. I'm going to go cry after this.
No, don't cry.
Okay. Oh, I like this one. I spent a lot of time researching this one afterwards because I thought it was really interesting. But,
Oh dear.
Okay, so at the beginning of the universe, there is just hydrogen and helium. At the beginning of the universe, there's just hydrogen and helium, right? And then we get star formation later. So the very first stars that formed were called first generation stars. So the statement or the fact or fiction is... Our sun is not a first-generation star. It is rather a third-generation yellow dwarf star. True or false?
Ooh. I feel like there's two parts to that.
Yeah.
The one being first, second, or third generation star. And then the other part being yellow dwarf. I don't think I've ever heard that terminology. Because I know I always get it mixed up. The sun is a G-type star. I know that. But interesting. And then you said third generation. I feel like this is a wild statement. The Milky Way is not that old. Like, it's old, but like comparative, like not that old. I feel like the sun would be maybe a second generation star, not a third. So I'm going to go.
To help you out here, I'm not differentiating so much on second or third as I am first or second or third.
Okay.
Like, is it first generation or is it second or third dwarf star?
I'm trying to think how old each of the things is. I'm going to say it's fiction. I'm going to go with fiction. Final answer.
Okay, so you're saying that our sun is probably a first generation star.
I'm going to go with yes.
Okay.
Yeah.
Is that your final answer?
Yes.
Okay. It is actually a fact.
What?
Yep. So our sun, if it was made by a first generation star, then that means that it was made only of the primordial gas that was after the Big Bang. So the rocks that made the Earth, the elements that made us, couldn't have existed. We all, like, our solar system has all formed from the same cloud of gas and dust that our sun formed from. So
That
it
makes
had
sense.
to be either a second or third generation. I read both. When I was researching, I read both second and third. I think I've read more about it being a third generation star than a second, but I saw a couple sources say second. So I'm going to say it's a third because I saw that more. But yeah, it's likely a third generation star. We can tell because of its metallicity, which in astronomy means like anything heavier than helium. So just not hydrogen or helium.
so just not helium.
Yeah, just not helium or hydrogen. And yeah, and it's pretty cool. And what else did I have I had a lot of fun stuff written down about this. Yeah, we like really awkwardly talk about population stars, like population 1, 2, and 3, which is the opposite scale of generation 1, 2, and 3. So if you're a population 1 star, you are a generation 3 star.
Okay.
So yeah, it's really weird.
That's so
concise.
So
the sun is a population 1 star that is in its it's a third generation star, part of population 1. There are two different ways to say like a similar thing.
When you were looking into it and like looking at the background research, did they specify like what the big difference was between second and third generation? Or is it just kind of like something they just said and didn't explain?
I think there's a relatively explicit difference. I'm not a master of this, so I won't say like definitively if it is or not, but I do believe that there is a way to tell if a star is explicitly like second or third generation because of its metallicity, what the ratio of heavy elements in it is. And yeah, for a second generation star to form, that means that it came from a first generation star, which fused only up until iron. So if you have anything other than iron in your system, I assume, actually no, because supernovas. So yeah, I don't know. That's a good question. I don't know. Yeah, that's a good question. But yeah, I'd assume that there could be a higher abundance of heavier elements in a type 3 star. But yeah, it's something to look up. It's a good question.
It's very interesting though.
Yeah.
I was thinking more on like the formation of our galaxy versus like formation of our entire universe. But saying that part, that makes sense that like, yeah, there was only a couple options in the beginning. There wasn't all of the things. Now we have all of the things and all of the options.
When I was looking this up, I was talking to my wife about it, and she was like, are there even any like first generation stars still being made? And I was like, of course there are. There's like so much hydrogen and helium left in the universe. But I looked further and I figured out that no, there's not a lot of first generation stars still being made. And we actually still haven't even found explicit proof. There may be proof right now. It's still getting researched, but we're on the brink of finding and detecting our very first generation stars, and that was with the help of James Webb Space Telescope. They looked at a star system in a galaxy. I forget the name. In a galaxy very far away. Actually, really, really, really far away. Like 14 billion light years away, nearly.
That's far as fuck.
Yeah, it's really far.
Isn't that nearly cosmic microwave background?
Yeah. No, I don't know exactly how far away the galaxy is, but it is like an early galaxy, so I'd assume it's really far away. I don't think I wrote it down. Oh.
No.
How rude of myself. Yeah.
How could you?
Yeah, I did not write it down. That is very unfortunate. But yeah, we believe that a generation 1 star may have been found in a galaxy that is being gravitationally lensed by a galaxy cluster, which is when a whole bunch of galaxies just like are near each other and bend space and create like a lens in space so we can see further. It sounds like science fiction, but it's a real thing that we use in astronomy. And we're able to see further at a higher resolution because of that. And James Webb has just looked at one of those galaxies. And so a team that's using the data from James Webb may have just found proof of the very first detection of a generation 1 star.
Which is very cool.
It is cool.
James Webb is cool.
Yeah.
I know everyone's dying for time on it.
Yeah.
And I've seen so many proposals, even at CU, of like, we want James Webb time. And they're like, no.
Yeah, my professor just put in a proposal. We're keeping our fingers crossed for him.
Wait, which professor?
Zach Berta Thompson.
ZBT!
Yeah, he's cool.
I love ZBT.
Yeah,
he's the best.
Cool. He was actually on one of our
mugs.
podcasts. He was on episode... No, not 2. It was like 6 or something, or 4.
Did he bring a mug with tea in it?
What?
Did he bring a mug with tea?
Probably.
I was going to say, otherwise that's a clone, and that's not...
Yeah, we don't have videos of him. We just had audio only, but yeah. He was in to talk about exoplanets. It was pretty cool.
No way. Yeah. Well, what else would he talk about?
6. Javid just confirmed it was episode 6.
Oops.
Nice. Yeah. So yeah, that's really cool. And back to your question before. Generation 2 stars are older than 10 billion years old.
Okay.
Our sun, I'm getting away from my microphone. Our sun is about 5 billion years old. I think it's like 4.7 billion years old or something like that. It's around 5 billion years. But yeah, so I think that is like more proof of it being a generation 3 rather than generation 2. But because I saw like multiple people say different things, I'm not entirely sure.
But also it's the internet, and people love to lie on the internet.
It's true.
That's their favorite thing to do on the internet, actually.
Yes. All right. So you have 2 points. I have 1.
Are you ready for your next one? Are you ready to be redeemed?
I'm looking for redemption.
Okay. Hopefully, if you listened to me rant at all last week, you will answer this correctly.
No, I have like really bad memory, so
I'm praying on it. Yes, I know. Okay. Earth is the only planet with aurora or northern lights caused by the sun only.
The sun only. Aurora has to have a atmosphere to cause. So is that what you're getting at? What
I'm getting at is a northern aurora caused only by the interaction of the sun with a magnetosphere.
In our solar system?
Mm-hmm. So Earth would be the only one. This statement is saying that Earth is the only planet that the only type of aurora it has is one where the sun is directly interacting with the magnetosphere.
No, that's fiction. I think that's fiction hardcore, because there's aurora on Jupiter and Mars, and I've seen them both at the North and the South Pole of them, like the magnetic North and South Pole. Mm-hmm. So I don't know a lot about how all of this works either, but I feel like just with how aurora works on Earth and the way that I've seen pictures of aurora on other planets like Jupiter and Mars and them being on their magnetic poles, I would say that's fiction Final answer.
You're correct.
Okay.
It is fiction.
Good.
So there's more than one type of aurora. There's not just ones from direct interaction with the solar wind and a magnetosphere.
I didn't even know that. That's crazy.
Yeah, there's I'll get into that part, but Earth really only has that reaction, but also Jupiter pretty much only has it due to its magnetic field. Jupiter's magnetic field stretches all the way out to Saturn. I think it was Juno, the Juno mission, or the Cassini mission, I'm forgetting which, that detected Jupiter's magnetic field at Saturn when it was flying by, because it's so massive. And so it does have aurora on both its north and south poles. But other planets, Saturn also has an aurora caused by the solar wind and the magnetic field. But it also has a little bit of aurora caused by the storms at the poles. So the actual wind and the wind patterns create more aurora on Saturn.
Yeah.
Which is really weird.
Because the winds are really fast.
Mm-hmm.
So
and also the swirling
Huh.
pattern, it goes like, I just saw like an example, someone did a simulation of like showing the winds. They kind of curve like that, and then it flips and goes the other way, almost like it's like a pretzel kind of shape. And so that also causes more aurora.
That's interesting.
And they're exploring like why. They know that that's part of the reason because they can watch it happen. But they're like, that's odd. Didn't know it could do that. Then let's see, we have Saturn, we have Jupiter. Then we also have Uranus, which is also caused by presumably just its magnetic field, though we're not 100% sure since it's further out, less missions. It could have similar things like Saturn. We don't know. We just haven't studied it enough. Nobody cares about Uranus and Neptune. Nobody loves them. But so far we think it's just that. And then Neptune as well, same thing, just at the poles. But the thing is the rotational axis and the magnetic North Pole are not even relatively the same. For Neptune, the rotational axis is still tipped, but the magnetic North Pole is at, I think, a 47-degree angle. So the aurora appears to be kind of like on the sides of the planet, but that's where the magnetic field is coming out of, and it's also very weirdly shaped. Very, very weirdly shaped. So those are weird.
Interesting.
But
I didn't even know that we had like discovered aurora on like all of the major planets, except, do you know about Venus and Mercury?
Venus and Mercury have had none as far as I'm aware. I think they're almost too close to the sun for some of the reasons of Mars's aurora, because Mars has 3 to 4, it's kind of debated, 3 to 4 types of aurora. One of them being an induced magnetic field. So the solar wind brushing around the planet and causing a magnetic field causes the more typical aurora. It also has like a patchy crustal aurora, which is caused from remnants of its original magnetic field that was stripped away when its atmosphere was stripped away. And then I'm forgetting, I think there's also just patchy discrete aurora is the third like confirmed type, which is not related to its patchy crustal field. And that's more just about on Mars in like weird, it's really weird. There's stuff with Maven that's taken a lot of pictures of it, as well as some stuff with the UAE as well and the Hope mission that have taken a lot of pictures and tried to kind of piece together what mess is going on, because it's not consistent in the slightest.
Nice.
And then aside of planets, also moons both of Saturn and Jupiter also have aurora as well.
I didn't even think about that. That's cool.
Io specifically has really, really crazy aurora. It has the most variety in color, I think, out of any that we've ever observed because of all of the like volcanic eruptions and all of the chemicals around it. It creates some really wacky colors.
That's cool.
So it looks freaky.
Wow.
And it's just it's still within Jupiter's magnetic field. And so it's causing those interactions on Io.
That's really cool. I didn't know that. Yeah, when I was working on the Maven mission as a undergrad researcher, there was one person on my team was specifically doing Mars aurora, and it sounded really cool. I never learned much about it, but it sounded really cool. But yeah, I've like never gotten to experience aurora science much other than like the cool like solar storms that we've had recently. But yeah, that's really cool.
The solar storms are really wacky. I was able to see behind Costco the aurora, which was wild because it's so bright. And I had a show upcoming at Fisk that Sunday, and I was like, I want to do an aurora show. So I locked in, and there was nothing in the system for anything other than Earth auroras. Yeah. And I think maybe like one thing about Jupiter from Fran had put in a bunch of stuff.
Nice.
And I was like, okay, I guess it's time to find stuff, because both auroras, not talked about, the sun, want to talk so much more about that at Fisk. And there's like nothing in there, working on that, hopefully soon. And then also Neptune and Uranus do not get enough love. So I added a bunch of stuff for that too.
Yeah, Neptune and Uranus is hard for me because they're like so featureless
you just look at them. They're not featureless. Nobody just takes pictures of them.
Yeah.
They're pretty far away. Go stand on the other side of a football field, and I'll take a picture of you, and you're gonna look like a blob. And then they'd say, yeah, that might be Hunter. It's just like a featureless man. That's a white man.
Yeah. That's a few more tattoos will be a little bit more colorful.
But you're that far away. How will they know? Yeah. You have no storms. Yeah. You are just a white man.
We've sent like New Horizons and Voyager past them, which we're able to get like close enough to see some features. But yeah, I think it's just like really hard for us to send constant things unless we send stuff right to them to get like a lot more exciting data about them.
That's how they got the couple things that they have about their magnetic field is during the flybys. But I'm very pro they should send orbiters to stay in orbit around them. I think that it would be very cool, and there's a lot to be learned. Icy giants matter too.
I agree. I was just thinking while you're saying that, I wonder if that would even happen in our lifetimes if we were to send them out now.
I think so. They need to kind of get on it, though.
Yeah.
You need to get it together.
I don't know how long it takes. I guess it's been 50 years since Voyager, right? It's been about 50 years.
I think so.
And it's like way out of our solar system, so
it also depends on where we are in relation to where the planet is in its orbit.
Oh, yeah.
That kind of matters, too. And also if we slingshot it. Yeah. There's a lot of factors.
I'm sure we would slingshot it.
Of course. Yeah. We like slingshots.
Okay, are you ready for your next one? We both have 2 points now, I think. Is anybody keeping track? Cool.
I think we do.
I think I've lost count now, but we'll.
I don't know.
We'll figure out later when we watch the video. Okay, are you ready?
Yes.
This one's a really fun one because so when I was doing research for this one, I was like looking up common like sayings about the universe that like some people know, like. Or things that we all experience, like people are like, why is the sky blue? And then people are like, the ocean. And we know that's not true. But like, I've been looking up other ones like that. And so I found one that I thought was pretty interesting because I have heard it before, but I've never actually known if it's true or not. And it is. There are more stars in the universe than grains of sand on Earth.
In the universe. So like total.
Yeah. Are there more stars in the universe than grains of sand on Earth? Or actually, sorry. As a statement, there are more stars in the universe than grains of sand on Earth. But I've never actually known if it's true or not. And it is.
I think that's true. Wait, hold on. I want to say it's true that there are more grains of sand. There are more grains of sand than there are stars in the universe. That's
so you're saying the opposite. You're saying there's more sand than stars?
I think I'm saying the opposite of your statement. Okay. I'm saying there are more grains of sand than there are stars.
So you're saying false to my statement?
I think so. Okay. My basis being I saw something recently talking about how there's more trees on Earth than there are stars in the Milky Way specifically, which is an interesting stat.
Interesting.
And so that's making me lean towards that your statement is false.
Okay.
That there are more grains of sand.
There's at least 100 billion stars within the Milky Way. Anywhere between 100 and 300 billion is where we're estimating. But there is, in fact, many more stars in the universe than there are grains of sand on Earth.
Really?
Yeah, so this statement is fact. There are more stars in the universe than grains of sand. And I actually pulled up real numbers of this. And I had to pull up a graph.
Not a graph.
A graph of really big numbers because I didn't know what like decillion was. That's a number, decillion.
Like what would that be? Like the 10 version of billion?
Decillion is 10 to the 33. That's not a number we're using for this. So I just pulled that up because I didn't know. I've never heard of decillion before. But there are an estimated of 2 trillion galaxies in our universe. And the Milky Way, which is like an averagely large galaxy, has at least 100 billion.
I think it's a perfectly fair and decent size.
It's good. It's good. But yeah, there's a lot of like galaxies that are smaller than that. So, but if you average it out and we take the 2 trillion galaxies, we say that there are about 1 septillion stars, which is a 1 followed by 24 zeros.
That's too many zeros.
It's a lot of zeros. So a septillion is 10 to the 24.
That's how many cookies we have at Fisk on Cookie Clicker.
That is, oh wow, that probably is.
I think that's the last time I looked.
Yeah, the navigators who are controlling the computers when you guys are watching movies at Fisk, they're playing Cookie Clicker.
They are.
Yeah.
Not me. I'm marked safe from Cookie Clicker.
Yeah, not me. I have played it once, but...
That's just the first thing. I'm sorry. That's the first. I was like, septillion. Where have I heard that before? Oh, Cookie Clicker.
It's a very big number. But yeah, so there's a septillion stars in our universe estimated, and we're estimating 8 quintillion grains of sand. So a quintillion is 10 to the 18. So there's 10 to the 18, or 1 with 18 zeros followed by it, grains of sand. And for stars, there's 1 with 24 zeros followed by it. So quite a lot bigger, actually. There's many more stars than grains of sand on the Earth, which is pretty wild to think about.
That is. Okay, that's interesting.
Yeah. So if you just reach your hand into like a pile of sand and hold all that sand, that like, I don't know, I think of like comparing that to if I was like this giant that was bigger than the universe and just reaching my hand into a pool of stars, I guess. I would have more stars than I would sand in my hand.
I would eat the stars if I were a giant.
Oh.
They'd be like gushers. You're a giant. You're scooping up a handful of stars.
Yeah.
Would they not be like gushers? But like opposite of gushers.
Maybe that should be the next
outside,
question.
Hard on the inside?
Stars are like gushers if you're a giant. Fact or fiction?
Fact. I've eaten stars. They taste like gushers, obviously. They're
sweet.
Lemon flavored is like our sun, and then red giants taste like watermelon, not cherry, contrary to popular belief. And then like Sirius, for example, it tastes like blue raspberry.
That's exactly what I was thinking of. Yeah.
It's seriously delicious.
I like that. It's like the Lucky Charms thing, but not.
Oh yeah.
It's yeah.
Every commercial has like every commercial from the 2000s, I should say, has its little like cute quirk. Mm-hmm. Commercials these days don't have any flair. They have no sparkle.
Interesting. I don't watch many commercials. I mean, I think I like forcibly watch commercials a lot now, but I
avoid it when possible.
Yeah, I don't pay attention to them much anymore.
Fair.
Yeah. Okay.
Are you ready for your...
I'm ready.
Okay. I'm going to go in order of a very simple one, and then my last one will be very interestingly fun, hopefully. The last one's a history one. So we're going to go with one more planet one, and then a planet history one.
I know nothing about history, so
perfect.
That's good.
Okay. This one is, I think, my simplest. Ganymede is larger than Mercury.
Oh!
What is that reaction?
That's like, I don't know. Oh, that sounds like it could be true. So Ganymede is Jupiter's largest moon. Mercury is our smallest major planet. I think I've read this before, and I think it's true. Yeah, Ganymede is cool. It looks like a moon. It just looks like our moon, but it's big and really cratered, and it looks like Mercury. And that's about all I know about Ganymede.
No offense to Ganymede, I think it's one of the more boring ones.
Yeah,
and some people will yell at me for that, but it just visually looks uninteresting.
Yeah, it's very similar to Mercury. Mercury is like not the most interesting planet in my opinion.
I'm a Mercury hater.
Oh, well. I don't know if I'd say I'd hate Mercury, but...
I don't hate it. I'm a hater.
Oh.
Difference.
Okay. Interesting. I'm going to say that Ganymede is larger than Mercury.
Dun, dun, dun. Correct.
Yes. Okay, thank
It
God.
is a little bit larger than Mercury.
Okay.
There's a couple. I was debating which comparison to use between that and also possibly a comparison of Pluto to our moon. Because that's also one that people ask about. And I'm pretty sure we had this question the other day. During a show, someone asked if Pluto was larger than our moon. And
that was when you were like navigating for me when I was presenting.
Yeah,
and I didn't know the answer to it.
The moon is larger than Pluto.
Okay.
Which is
wow,
weird.
That's wild.
Yeah.
Huh. Interesting. That's crazy.
Yeah.
We just had Javid fact check that right now. He says, yes, that's true. That's crazy.
Did you think I would lie to you? Wow.
We have active fact checking going on right now.
We believe in fact checking in this house.
Yes. It's because I've said like a lot of things that are not true before.
You know what? That's so
I said
fair.
at least one thing that was not true last episode.
It's not that I intentionally misremember things. It's that I'll remember it exactly opposite of how it is. And then my brain perceives it as fact. And then I'm like, that is not correct.
Interesting.
Like,
I just intentionally misremember things.
Oh, okay, of course.
Yeah.
Of course.
I don't want to be successful.
Oh, understandable.
Yeah.
Respect.
Okay, I'm looking at my other one. I think... Yeah, I'll do that one. Okay. Are you ready?
Yes.
If you were to shrink the Earth down to the size of a cue ball, it would feel perfectly smooth. Fact or fiction?
A cue ball?
Yeah, like a billiard ball, like a pool.
Like pool?
Yeah, pool.
Is that what those are called?
Yeah, I think so. I don't know. Cute, yeah. Javid fact checked it.
In his brain.
Yes.
Okay.
I think I only called the white ball the cue ball. I don't play this game very often.
I don't either. I lost a crossword yesterday because I didn't know anything about pool.
Oh.
It's the only one I couldn't get.
Shoot.
Yeah.
Yeah. Are they all cue balls or is it just the white one? Oh.
Okay, well, we can pretend it's...
Well, if you shrunk it down to the size of a cue ball, specifically the white one, it would be smoother than that, like given like the deepest trenches and the largest mountains. If you were to shrink Earth down to the size of a cue ball, it would be perfectly smooth. Fact or fiction?
I'm going to say fact. I'm going to say fact because I feel like to us, we are very small. And, like, the features on Earth are massive. But if we're in space, I mean, looking at Earth, it looks relatively smooth. Most planets look relatively smooth. So I think if we shrunk it down to the same size, it would feel smooth. Because even, like, a cue ball or, like, this globe, great example, like, it's pretty smooth. We would consider this smooth. But, like, I can see divots on it. I can see little marks where it's, like, not perfect or scratches on it that if we were shrunk to this size, that would be like a massive cavern or something.
My statement is specifically that it feels perfectly smooth.
I think it would feel perfectly smooth.
Okay.
At least feel perfectly smooth.
That is
Final
true.
answer. Okay, yes.
Yes, that is true. Yes. So the deepest part on Earth, the Mariana Trench, is 7 miles deep. And the highest point on Earth, Mount Everest, is, I think, 5.5 miles above sea level. So that's like 12.5 miles from the lowest part to the highest part. But the diameter of Earth is 8,000 miles. And so if you compare like 7 to 8,000, that's really, really small. And if you were to like shrink that down relatively to the size of a cue ball, I read somewhere, I didn't do the math myself, but I read somewhere that that difference would be like smaller than the size of an atom. So we wouldn't be able to feel any bumps in it with our fingers. So that is much more bumpy than the Earth would be if it was that size. likely.
Imagine if that was our Earth. It would have weird ridges.
Yeah. Oh, yeah. And I actually looked this up even further, too, because I was trying to figure out, like, what are considered the highest points on Earth. And I saw that Mount Everest is, in one way, considered the highest point on Earth. It is if you're looking at it relative to sea level. But there's, like, 2 other highest points on Earth. And one is, like, relative to the center of the Earth.
Ooh.
Because the Earth is spinning. It has, like, a centrifugal bulge around the equator.
Yeah.
They call it an equatorial bulge or something like that.
I think that sounds right.
Yeah, and so the Earth isn't perfectly round in that sense, but I looked up how big the bulge is, and I was like, would we be able to feel the bulge if it was like the size?
So the question you're posing is, if Earth had a bulge, could you feel it? Do tell. What did your research say?
Oh, that is horrible.
Nobody thinks what I think.
That one's not going on the radio.
It's not? No way.
Oh.
That's so PG.
Yeah, I support that. Okay, so yeah, if you shrunk down Earth, could you feel its bulge? No, you couldn't. You wouldn't notice it. It'd still feel perfectly round. because the bulge is about 27 miles higher than, like, I know, it's big bulge energy. But yeah, it's that big. 27 miles big. But yeah, like, still, like, 27 miles compared to the 8,000 is still, like, nothing. And again, it's about the size of an atom.
Perfectly average sized. What do you have against the Earth? The Earth has a great personality, okay?
And a 27-mile bulge, for those that care.
Who cares?
Yeah, and then there's also another, like... Oh, yeah, the tallest mountain from, like, the base to the peak. That was another thing. And that is Mauna Kea in Hawaii.
Oh, really?
Yeah.
I believe... Mr. Fact Checker, I believe that is where NSO's main telescope is on or near that mountain.
Drum roll. Oh, yes, it's true. Good job.
This is true. Great. Fantastic.
Very nice. Very nice. So, yeah, you were right. Yippee! Congratulations. You did splendid.
I won a prize.
Does anybody know what our scores were?
I have one more. You're not done yet. Because you went... Wait, hold on. Yeah, I have one more.
Yeah.
I have one more. I have 5.
Sorry.
5 total. Wow.
Sorry.
You're trying to quell women's voices.
Yes, I apologize. Let it know that on the record that I apologize.
No. Okay, are you ready for your last one?
I am ready.
Okay. The Romans developed a similar 365-day calendar before the Gregorian calendar that was based on something to do with Sirius.
Based on Sirius?
Mm-hmm.
Okay. Similar calendar. Yeah, I'm going to say true.
Final answer?
Actually, yes, definitely, because because the zodiacs, yes, and they just didn't account for leap years, right? I don't know anything about history, but I remember that, like, zodiacs are arranged in a very similar way to our calendar now. So yeah, I'm gonna say yes.
The answer is false.
Oh, what?
Uh-huh. It's almost correct.
Almost correct. Okay.
So the Egyptians developed a 365-day calendar. Mm-hmm. It did not account for the leap year, but they made observations of the Nile flooding in Sirius, and they kept track of those two things, and that's how they calculated, and that was the basis of them deciding to make it 365 days. Is they watched those two things, both the Nile River's flooding and where Sirius was in the sky.
What was physically making the Nile River flood? Spring?
Just the season. The
Wait,
Nile.
no. Sirius would be coming up in the fall.
Sirius was just the star that they chose. There's a couple other. I believe, if I'm not mistaken, Sirius was in one of the constellations that was relevant to them, which is why they chose that one. Those were just two of like the big things that correlated to the 365 days. Those were like two things that they cared about and that they kept track of.
Interesting.
It did not account, though, for the leap day. And I believe, if I'm not mistaken, it went Julius Caesar's calendar, with him adding August and July and making all the numbers not make sense. And then the Egyptian calendar and then the Gregorian calendar, which added. It's either, I forget which one came first. It was either the Egyptian and Julius's might have been flip-flopped, but around the same time. And then Gregorian adding in the leap day, which is very important.
Interesting. Yeah, I did not know. I'm so bad with like astronomy, history, and just history in general.
That's fair.
Yeah.
A lot of stuff has happened on the Earth. There's a lot going on.
It's very true. That's very interesting, though. So, how similar was theirs then?
Almost identical.
So, it's false, though? Because theirs was based off different things. They were all cultures, not all cultures, that's definitely not correct. Multiple cultures were making the correlation of trying to like have a good calendar based on something that would stay consistent. And so multiple came to the same kind of conclusion. And then later on, we obviously added in the leap day because we were like, this is not precise. But the Egyptians specifically was Sirius and then the Nile River flooding. But me saying the Nile River flooding would have given that away immediately, that it was not the Romans. Because they're over there. True. Rome was like doing work in Egypt, but I don't know if they completely conquered Egypt in the Nile or not.
Rome was built in a day.
That is a fact.
That is 100%.
Did it fall in a day?
Yeah, it was like a 24-hour. It was like a pop-up shop, like in the mall.
That's what made the calendar.
Yeah.
How many times Rome could fall in 365
times? Yeah.
Rome falls.
Yeah, and then they were like, "Okay, cool. This is like our calendar." That's literally history.
Yeah. Wonderful.
Go ask a Roman. They're not going to disagree with me.
Okay, wait. Let's figure out how many points we all got. Okay, so you guessed correct. This is your correct pile.
Okay.
A planet has been discovered around a system with 4 suns. You guessed that one correctly. We have detected dark matter. Did you guess that one correctly? Yeah. She did? Okay. So we've tallied up the scores. We are tied 3-3 now, and so we need a tiebreaker.
Very serious business.
We've asked the producers to come up with a question for us to break this tie. If we both say the same thing, we're just going to have to keep going, I guess.
We're going to be here all day.
Yes.
Okay, so this one's going to be about black holes, specifically about the Schwarzschild radius of Earth. In order to make Earth into a black hole, you will have to condense it down to the size of a bowling ball. True or false?
False.
Got a false. What do you think, Hunter?
I think the Earth could be bigger than a bowling ball to turn it into a black hole. I think a bowling ball is smaller than it would need to be.
Ooh, interesting. I'm the other direction.
You're both saying false, but for different reasons.
I'm saying false. It's smaller.
Okay,
false
so
smaller. You're saying.
Okay, so yeah, we could actually do like who's closest to the truth. Then
that's good.
Yeah, I'm saying false. It would turn into a black hole at a bigger one.
I'm thinking it would be smaller.
Okay. Survey says, Raven, you are correct.
Would it be like golf ball size?
It is penny sized.
Penny, damn.
Oh,
yes.
Darn.
It is about 8.87 millimeters in radius.
Huh.
Yeah.
Okay.
So if the Earth were to be condensed to that size,
I could wear it as an earring.
Before it turned into a black hole, which would probably be instantaneous.
That's not my problem.
It'd be really, really hot if it was like just a little bit bigger than that.
It would be. I'd be very stylish. Thank you for pointing that out. Anyways.
It'd be a black
Moving on.
It would be
Black hole
like,
during would
yeah.
really, really cool.
No. It would be temperature hot.
Anyways, moving on.
That's cool. I was. What is the source field radius of a human?
Ooh.
That's what I was thinking of during it, and I thought like,
Wouldn't it be
my
like
first thought that was like the size of a pea, but that's way too big. I think it's like much smaller than that.
the size of a mushroom spore?
I think it's like microscopic,
No,
nearly. Yeah.
Yeah.
Approximately 1.04 times 10 to the negative 25 meters.
That's a lot
That's
smaller.
small.
That
Than
is smaller than
Yeah.
an atom's nucleus.
Yeah.
Oh.
Oh wow.
Ow.
So the black hole that would be created would evaporate instantaneously.
Yeah.
Okay, but was that a small person or a large person?
Average
Average
person.
Okay.
Hmm.
Interesting.
What if it was a big person? Wait, what was you said? 10 to the negative 24?
25.
25? So I think a big person would be negative 23. Thank you for coming on the show and playing the game with me. That was fun. Yeah, and come back onto the show sometime.
Thank you for having me. It was very fun. I like winning.
Yeah, winning is good.
No.
Do you want to tell the people anything?
I thought there's no calls to action.
Not on the radio, but on YouTube.
What do I want to tell the people? I don't know.
Some wisdom.
Everybody needs a thneed.
The what?